Hello everyone, welcome back to CloudOpsCraft. Today we are going to discuss about pods and ReplicaSets, the building blocks of Kubernetes. Let's imagine this. You are running a restaurant. Each chef in your kitchen is responsible for cooking one dish. They have their own tools and a recipe. Okay. Now Kubernetes works almost the same way, except instead of chefs we have containers, and instead of your kitchen we have pods. Okay. What is pod? Any idea? What is pod? Actually, pod is the smallest deployable unit. Let me zoom this better. Pod. Pod is a smallest deployable unit. Okay, in Kubernetes, you can think of it as a wrapper or enclosure around one or more containers that work together as a single logical unit. If Docker is about running a single container, Kubernetes says let's group containers that must always run together. Okay, why Kubernetes uses pods, not just containers? The thing is, Kubernetes does not schedule individual containers directly, it schedules pod. Why? Because sometimes a single application may need two containers working together. In a main up container running nginx server as a site, and a sidecar container like a fluentd collecting logs. Okay, both should share network, same ip, same port space, storage also with shared volume, right? So Kubernetes group them in one pod, ensuring they always stay together, deployed, restarted, and scaled as one unit. Okay, inside a pod, when a pod is created, all containers inside it share one network namespace, meaning they can talk to each other via localhost. Okay, with the localhost itself, all containers can communicate inside the pod. Okay, because they are all are sharing one network namespace. Okay, they share storage volumes for data exchange. They are managed together. One pod equal to one scheduling unit. Okay, if one container inside the pod fails, the Kubernetes can restart the entire pod, or the specific container depends on the configuration. Okay, while coming to pod lifecycle, pending, first is pending state. Pending means waiting for scheduling, or actually, let me explain one by one. While coming to pod lifecycle, first is pending state. Pending, waiting for scheduling or image pool. Second is running. Containers are up and running. Third is succeeded. All containers exited successfully. Fourth is failed. One or more containers failed. Unknown. Node or status info not available. Kubernetes constantly watches this life cycle through its control loop. Okay, let's create a simple pod. We already created a Kubernetes, like a Minikube, right? Minikube for Kubernetes, right? Let's create a simple pod so you will understand it in better way. Okay, so let me open terminal. Okay, now let's check whether Minikube is running. Okay, Minikube start is the command. Okay, we can use to check whether Minikube is running or not. Okay, Minikube is running. Okay, let's create a simple pod. Okay, simple YAML file, and I will explain how containers is creating. Okay, so let me create one folder called deep, like a pod. Okay, pods, not like that, like I'll make it as kts. Okay, so kts. Now I'm going to just create one YAML file, which is vi nginx dot YAML. Now we are going to write a YAML file because Kubernetes uses YAML. Okay, uh, okay. So we are going to use YAML and we are going to create a pod. Okay, so first we have to provide API version. Okay, version API version I'll just provide as v1, which means this tells Kubernetes which API version this object uses. Okay, v1 is used for core Kubernetes objects like pod, service, config map and all. For those things we will use v1. Okay, different objects uses different API groups and versions like apps slash v1, networking.kts.io slash v1, etc. Okay, so next is pod. Next is kind. Here we are going to create a pod, right? So in kind we have to provide as a pod. Okay, kind what it indicates, this specifies what type of Kubernetes object we are creating. Okay, pod is one of the Kubernetes object that we are creating, so I have mentioned pod. Okay, here we are creating a pod. Okay, pod is a smallest deployable unit in Kubernetes. A pod can contain one or more containers that share the same network IP and volumes, etc. Okay, next is metadata. Metadata name I'll just provide as my app pod. Labels is I'll just provide as app and my app. Spec is containers name nginx container. Image. Okay, the thing is in metadata what we are doing is metadata contains identifying information about the pod. Okay, your name is my app pod, which is name of the pod, must be unique within the namespace. Okay, so labels, namespace and all we will discuss in upcoming classes. Okay, so labels is a labels or key value pairs used for grouping, selecting, filtering Kubernetes resource. Okay, and app my app, I have provided label as app my app, which means pod is this pod as a label app equal to my app, useful for serving services, selecting pods, deployments and replica set, tracking pods, filtering using kubectl get pods -l, app equal to my app, like that you can filter. Next is spec. Okay, this is a desired state of the pod. Everything inside spec tells Kubernetes what containers to run and how to run them. Okay, next is containers, which is a list of containers inside the pod. A pod can have one container, most common, or multiple sidecar pattern. Okay, next is name, nginx container. Okay, this is the name of your container inside the pod, used in logging, used in debugging, helpful when your pod has multiple containers. Now image I am going to use nginx. Okay, the container image to run. Okay, Kubernetes pulls this image from Docker by default. It runs the official nginx web server image. Okay, now I'm going to allow the port. Okay, port, I'm just going to run this on ports hyphen container port 80. Okay, so what it indicates, let me open this container port. What it indicates, this section defines which port. Okay, this this section defines which port the container exposes internally. Here container port :80, which means it declares that this container listens on port 80, useful for documentation tools like kubectl describe, automatically mapping ports when creating servers. Okay, important is container port 80 does not expose the pod externally. Okay, it only tells Kubernetes that hey, this container listens on port 80. Okay, to expose it you have to use node port or cluster IP with port forwarding, or you can use ingress. That and all we will discuss in upcoming classes. Okay, so this is the thing. Now if you want to run this YAML file to create a pod, means how to run, there is a command. Okay, we know kubectl is a CLI tool. Okay, so we have to use kubectl only to create a pod. So kubectl apply -f name is nginx.yaml. Now we have created the pod, you can see. Now let's check this. The command to check this is to list the pod is kubectl get pods. You can see this is the pod that we have created in our last class. This is the pod that we have created now. Okay, this will show your running pods. Okay, the running pods under the hood. Kubernetes will ensure the container is created on one of the nodes. Here we are using minikube. It has only one node, so it by default it will point to this server only. Pods are ephemeral in nature. They don't self-heal, which means now here is something most beginners miss. Okay, pod does not heal or reschedule themselves if they die. Okay, if pod crashes, Kubernetes won't automatically bring it back unless something higher level manages it. That's where replica sets comes in. Okay, that's where replica sets comes in. Any idea on replica sets? Just pause the video and let me know on comment section if you have any idea on replica sets. What is a replica set? A replica set ensures that a specific number of pod replicas are always running in a cluster. If one pod dies, replica set immediately creates a new one to maintain the desired state. Think of replica set as the restaurant manager, ensuring there are always 3 chefs in the kitchen. If one chef leaves, the manager immediately hires a new one, so service continues. Okay, let's create a pod. Okay, so let's create a replica set. Okay, for our newly created pod. Let's do that. Again we have to write an YAML manifest. Okay, so this time let me save this as replica set.yaml. vi replica set dot yaml. Okay, let's start. Okay, first is API version. We should be capital. Okay, once you started working with Kubernetes, you will remember this. Okay, initially it is difficult to point out all these things, but once you get experience, you can do it. Okay, app. It's not app2. It's an apps.app/v1. The thing is, here we are previously we have used only v1. Okay, but here we are using app/v1 because this tells Kubernetes which API version to use. Apps/v1 is required for replica set, deployments, stateful sets and all. You can go with apps/v1. Okay, for config maps, those things like pods, services, you can go with v1. Okay, next is kind. What kind we have to use? Do you know? Kind is a Kubernetes object. Here we have to use replica set. Replica set specifies what you are creating. Here you are creating a replica set, a controller that ensures a fixed number of pod replicas are running. Okay, next is metadata section. In metadata, I'll just provide metadata. Contains identifying information about the object. Okay, name I'll just provide as my app -replica set. This is the name of the replica set. You will use this name when running commands like kubectl get rs or kubectl describe rs. On the time you will use my app -replica set. Okay, this is the name of the replica set. You will use this name when running commands like okay, this like kubeget or rs and rs stands for replica set. Okay, next is spec. Okay, in spec what we are going to write? Any idea? Let me write spec. What we are going to write? Any idea in spec? What we may write? We have to provide our replicas. Okay, so spec Okay, replicas. Replicas. I'll just provide three replicas here. Three replicas, which means, first let me explain the spec section. Okay, it defines the desired state of our class, our replica set. Spec, inside this we describe how many pods to run, which pods to run, the pod template to use. Okay, replica set colon 3 means you want 3 pod replicas of this application running all this time. If one pod dies, replica set creates a new one. Okay, if extra pod appear, replica set deletes them. Okay, by default it will have 3 pods. Okay, since we have provided 3 as a replica set. Now we are going to use selector. Selector match labels. Match labels. No, it should be here. Like in real time, mostly we will use Visual Studio Code with YAML validator. Like, okay, so YAML syntax. There are so many extensions are there. We will use that, so we no need to worry on index indentation. Okay, app. What label we have given in our pod, which is my app. So I'm just going to use that. Okay, the thing is, here in selector what it will do is, it's an important one. Okay, the selector tells the replica set which pod it should manage. Okay, match labels means replica set will look for pods with specific labels. Okay, here our label is app colon my app. Okay, replica set will manage only pods with the label app my app. This is our pod label, so it will enable replica set only for that pod, not for everything. Okay, without this, for example, if you are having 100 pods, okay, how replica set knows which pod it should replicate, right? So match label is a must. That's why while we are creating a pod, we just provided the label. Okay, we are just using that label here as a match label, so replica set will match this label with pod. Okay, and it will replicate the pods. Okay, this is the concept behind it. Okay, next is pod template. Okay, next is template. Okay, template metadata. First is metadata. We have to provide the metadata. Labels app my app. Spec is containers. Okay, let me explain this template first. Okay, template section. This section describes how the pod should look. Okay, everything inside this is essentially a pod definition. Okay, metadata, which means metadata for pods created by this replica set. Next is labels attached to every pod. This must match the selector above. Okay, app equal to my app, which means the label ensures pod match the selector. Replica set recognizes and manages them. Okay, next is pod section. Pod spec section. Okay, this spec defines what's inside each pod, and containers is a list of containers that will run inside the pod. Even a single container must be placed inside a list. Okay, so first I'll provide what image we are going to run here, which is nginx. Image nginx. Okay, so I hope you are clear. Okay, let me save this. Okay, now we will apply and verify it. Okay, so kubectl apply -f replica set. We got some error. Okay, which is under version v1. Okay, let's open that. Vi replica set app/v1. We have used app/v1. Okay, kind is correct, metadata is correct, spec also correct, replica set, selector, match labels, app, template, metadata, labels, app, everything is correct, but it is showing on here only, right? What is the issue here? App slash v1 only we have used, but from because of that only we are getting this issue. You can see here, it is we are getting issue on spec. Okay, so let me open it again. Here we are using one spec, replica set, selector, app, template, metadata, labels. Okay, this spec should be under metadata, not under the template. Okay, that's the issue. Let's fix this. The thing is, in real time you can use Kubernetes extensions, so it will correctly point out. But since here we are learning, I'll just writing by my own. Okay, once you got familiar with the once we add some what I can say, once you are familiar with YAML validation, then we can go with Visual Studio Code. Okay, next 2 to 3 classes, or at least 1 or 2 classes, we will go with terminal. After that we can go with Visual Studio Code. Okay, so if you are going with terminal, if you are getting any issue like this, we can fix it. Okay, that is the thing, nothing else. Okay, in real time you can use anything, that's not an issue. Okay, here just to get familiar with the YAML, like I just went with terminal. Okay, so now if I use kubectl get pods, you can see replica sets. It should create one more. There are 2 replicas are there. Yeah, this is the pod, so this is the replicas of those pods. Okay, let type kubectl get rs to get replica sets. You can see 3 replicas. It has 3 replicas. Even if I delete one, it will create one new one. Okay, let's check kubectl delete. It has been deleted. Now if I go again, it will create new one. You can see 4 seconds ago. Okay, it will ensure that 3 pods are up and running always. Okay, it will maintain the desired state. Okay, okay, it will maintain the desired state. Okay, which means if you provide 3 as a replica, it will maintain 3 pods. Okay, if you are providing as a 2, then it will provide 2. Okay, it will maintain 2. How replicas work internally? Replicas continuously monitor the cluster. They have 2 key fields. One is spec.replicas, which is desired number of pods. Next is status.replicas, which is actual number of pods running. Kubernetes control loop compares both. Okay, if there is a mismatch, it creates or deletes the pods automatically. For example, consider we have a decide state here 3, right? So decide state is 3. Decide state is 3. For example, actual you have only 2 means it creates a new pod 1. It creates one new pod. Next is if decide state is 3 and actual is 4, then it will delete one extra pod. Okay, next is labels and selectors we have used here, right? Labels and selectors we have used. Even I have explained this, but still let me provide much more info. Replica sets identify which pod they manage using labels. Okay, if your label matches the replica set selector, it belongs to that replica set. So labels are like name tags on your chefs, and replica set says I'll manage everything chef. Okay, by wearing this name tag. Okay, let me show you. So if I use if I show you Nginx, here you can see label I have used as my app. Okay, again if I use replica set, okay, in replica set also I just used match labels and template labels as app, colon my app, because what it will do, this selector finds which pod matches this label. Okay, and this template, what it will tell, okay, okay, after finding the pod, it will it will tell that we have to use this template to replicate, uh, to manage it in a replica set, like that it will decide. Okay, so these two are major things. Okay, that's why label consistency is crucial in real time. Scaling replicas is easy. Okay, you can scale pods easily by changing replica counts. Okay, here from, if you change this to 5, and if you reapply it, it will create 5 replicas. Okay, otherwise you can simply use scale command to scale. How you can use scale command, kubectl, but in real time everything we will do it in a code. Okay, so then only we can able to track it. Okay, as well as if you are not updating in YAML file, again if someone is running that YAML file, then it will re-update it. Okay, that's why always update in YAML, but just to show you the command, because you can easily update here to 5, right, but you don't know how to scale, right, so in command, so I'm just showing you that. Okay, replica set hyphen replicas. Okay, it is scaled. Okay, now if I use kubectl get pods, you can see it is managing 5. All 5 are up and running. Okay, Kubernetes instantly spins up more pods to reach the desired state, or you can simply modify. Okay, and reapply. Okay, modifying YAML is the best practice. Okay, instead of using scaling command, replica set handles the rest. Okay, so next, why we don't usually create replica sets directly? Because why we need pod, we can directly create replica set, right? You must have this question. Let me explain. While replica sets are powerful in real world use case, we rarely create them manually. Okay, instead we use deployments, okay, which internally manage replica sets for rolling updates and version control. Okay, we will learn about deployments in upcoming videos. Okay, but replica sets are the backbone behind them. Okay, so this is all about pods and replica sets. Okay, if you like this breakdown, subscribe to CloudOpsCraft. We will simplify cloud and DevOps concepts every week. Thank you.